General relativity, step by step. I've got this nice equation here for tidal accelerations on starting from the assumption that they move on Einsteinian geodesic lines, that the particles move on Einsteinian geodesic lines, and this gives an expression for my tidal forces. I'm going to compare this with d2ni by dt squared as calculated by Newtonian gravitation. So that's di2 phi by di xi di xj n j. And I'm going to write it in a slightly different format. It's going to be equal to minus eta ik di2 phi. Phi, of course, is the gravitational potential, grav part phi, by di xk di xj nj. So directly comparing these two things, I can compare this thing here and this thing here, and observe that in the Newtonian limit r I ojo, which is this thing here, equals this thing here, eta, I'll write that out a bit more neatly, eta ik di2 phi by di xk di xj. I had to pause for a little while there because I wanted to make sure this equation was tensorially correct, and it is, although well, it is what it is. I'll write the I in there in red. The k is summed, so I'll write that back in black, I guess. There's the k and there's the k, and the j on the other side I'll write in green, which is this one here, j and j, which is a free index on both sides, summed over k. The zeros are problematic. I mean, they're repeated but they're not summed, they're just a specific value. They should really be in a different font or something like that. Anyway, so we've got this rather nice equation here, which we can now use to start pinning down this constant k in the field equations. Okay, so how do we do that exactly? Well, what we need to do is to remind ourselves what we need to do is to remind ourselves what Newton's law of gravitation is. 4 pi rho. That's just Newton's law of gravitation. Law of gravitation. So what we need to do is to figure out how to express this. This is Poisson's. Is it Poisson's or no? I think it's Poisson's equation. I need to figure out how to express this thing here in terms of tensors. Yep, and I'll do that on the next screencast. So I'll stop there. Stop.